doubly reinforced beams. So in a typical design procedure, in designing beams, we always start with the determination of MU, okay? Wherein this MU can be taken or solved from the structural analysis. So remember in your structural analysis course, you solve for the maximum moment, maximum shear, or maximum forces being applied on a beam or a member. So from there, we can solve MU. Now, in designing beam, we have the MU. Normally, from the MU, then we design for the section of the beam and then the number of reinforcement. So we solve the D, the area of bar required. So that is the normal procedure in designing. Now, before, um, in our time, we normally solve from B, determining the B or the width of the beam, and then the effective depth of the beam. And then from there, we solve the area of bar. So in every design, we make sure that the design is singly reinforced. Okay, that's our previous topic, singly reinforced. So kung singly reinforced, we know that in the singly reinforced, the reinforcement is only at the bottom, AS, or on the top on in the case of negative moment. So for positive moment, the reinforcement is in the bottom, but we only have one reinforcement that is singly reinforcement. So ganun yung pag-design. Determine muna natin yung B, D, and then once we have the dimension, we determine the AS. That's on our time. But now, um, because of the use of computer and it's with the use of computer, it's easy to iterate. So we na in the recent design approach, we always assume first the B and then the D. So we assume first B and D, and then from the assumption of B and D, so in practice, that is typical, but or by experience, we can assume the let's say we have, when you're designing 6 meters and then two-story building, ganon. So, by practice, you can estimate na yung ano yung width ng beam at saka depth ng beam. So, in NSCP, we have the minimum depth ng beam. Like yung nabigay ko sa notes, like L over 16, kung simply supported, ganon. Um, Forgot the details already about that, but we have the rules on what is the minimum depth. So in in the steps now, we always assume the B and D, and then from there we compute the AS. Okay. Now, if now once we have the assumption and then we solve the AS, now if mag-turn out na ang capacity ng section natin, or we say phi mn max, maximum capacity ng section is less than mu, meaning hindi niya kaya yung mu. Kasi nga, mayroon tayong computed na maximum nominal capacity ng maximum ultimate capacity ng section. So what do we do if VMN max is less than MU? So in here, we can adjust kasi nga, nag-assume lang tayo ng B at saka D, right? So we can adjust the section, maybe we can enlarge the section, okay, larger value of B, width, and then a deeper value of depth, D, okay? And then we'll compute again the VMN max if until we reach that VMN max is greater than MU. Then we say it's okay now. Okay. So we keep on iterating until we reach this we can satisfy this equation that the capacity of the section is greater than the actual moment. So, yun, hanggang dun, ito ang approach ng singly reinforced when you are designing a section for a specific MU. Now, but in practice, um, most of the time we do not have the freedom for the section of the beam. Okay. Sometimes the architects they specify the maximum depth ng beam. For example, let's say one story, I mean 2-story residential building. Let's say the architect specify na dapat yung depth lang ng beam is let's say 300, maximum depth niya is 300 mm. Ganun. For a span of let's say 7 meters. Yun. So, limited lang. Wala kang freedom na mag-adjust na to satisfy the maximum moment. So, anong mangyari dyan? Kung limited na yung section mo, and then i-compute mo yung mayroon kang limited na B at saka limited na depth D, then compute mo yung maximum capacity ng section, it turns out na nag-fail siya. I mean, hindi kaya ng maximum moment. You can go back to the architect and say, architect, can we adjust the section? But most of the time, the architect insists na, no, we cannot adjust the section. Yun lang talaga may bigay natin na maximum depth. Okay? So, in that case, we cannot analyze or design a beam for singly reinforced. So that's the time we proceed to doubly reinforced. Okay? So, what is doubly reinforced beam? Ang singly reinforced, if you can remember, that is ang mag-create ng moment ng section to resist the load moment is the couple. Remember? Couple of the compression due to concrete and the tension due to steel. Right? So, wherein ito minus A over 2, if you can remember. So, yan yung mag-create ng couple, compression ng concrete at saka tension ng steel, right? So that will create the moments, nominal capacity ng couple or ng section. Now, in doubly, kasi nga we cannot adjust the section anymore. So we need to add another moment. Okay? So how can we do that? We cannot add additional compression because yun na nga, ang section ng concrete is limited already. But we can add additional tension. Okay? So we will add additional tension sa baba. Okay? Tension. Let's say tension 2 if this is tension 1. Okay? So this is tension 1 and then we will add another additional bar sa baba, tension 2. Now, hindi pwede na mag-add lang tayo ng reinforcement sa baba lang, di, nawala sa taas. Kasi nga, we need couple, right? So kung isa lang, hindi na ito matawag na couple. It will not produce a resisting moment for our MU. So that means, kung mag-add tayo ng compression, I mean tension sa baba, dapat mag-add rin tayo ng compression steel. Okay? So let's call this compression steel, CS. Right? So yan, parang couple na rin siya. Okay? So dalawa na yung couple natin. We can call this M1 and then this is M2. Okay? The first couple is from the tension steel. Let me have marker. Okay, so ito yung first couple. Tension steel 1, you can see there, and then the compression of the concrete. That's the first couple. Second couple is tension steel 2. So may additional tayo na rebar. Okay? Yung TS2 is aside pa yan siya sa TS1. Okay, additional pa yan siya. And then, kung ano yung idinagdag natin sa TS2, yun rin yung dapat idagdag sa compression steel dito sa taas. Okay? So here, we have compression steel. So sa taas, compression. Yung steel dito sa taas is under compression na siya. Okay? And then sa baba is under tension. Okay? So the same sa tension 1, under tension pa rin siya. Okay? So yung compression lang natin, if you notice here, yung compression natin, mayroon tayong compression due to concrete. Okay? Mayroon din tayong compression due to steel. Okay? Sa baba, tension 1 at saka tension 2. Okay? So, in the proper analysis, this is how we analyze a doubly reinforced. Let's say we have a section. Okay, we have this section, and then with width of B, and then depth of D. And then we have our this is total rebar already. So, we don't know if how much dito yung AS1 at saka how much yung AS2. But we can say that this is the total area of rebar na nasa baba ng beam. And then AS prime, ito yung compression steel. So, ang AS prime is at the distance D prime. You can see there, D prime. So, in the stress block analysis, hatiin natin sa dalawa. Okay? Although the total couple is, we call it the MU, or actually that's the VMN. And so the first couple can create MU1, the second is MU2. Okay? So the first couple is, if you can see here, this is our first couple. So compression. So this one is parang singly reinforced siya. Right? Ito yung singly. Right? Compression sa taas ng concrete at saka tension sa baba ng steel. So parang the same, ang analysis nito is parang singly reinforced din siya. May nadagdag lang na ito, pinalabas ko na lang sa section. At meron tayong AS prime ah, at saka AS2. Okay? So, nag-add tayo ng compression steel sa taas, which is AS prime, and then the tension steel sa baba na AS2. Okay? So, in the analysis, yun, ganito pa rin siya, yung compression ng concrete, we call it CC. You can see there, ang compression ng concrete is still 0.85 FC prime AB, where A is A is the depth of a stress block, okay, which is still the same. A is equal to beta 1 times C. Yan. Where C is itong C, ito yung distance from the top fiber to the neutral axis. Okay, so they have a distance of D minus A over 2, and then the tension steel, remember in singly reinforced we have ASFY. So in tension steel here we have AS1 FY. So ito yung first couple, 0.85 FC prime AB and then AS1 FY. While the second couple, so ito medyo simple ang formula. Ang compression steel is ganun lang siya, area times stress. So this the area of steel AS prime times FS prime. Okay? And then sa baba, mayroon tayong ES2 times FS. Okay? So, or let me check. That should be AS. Um, sorry. Let me check if this is FS or FY. Yeah, that is FS. ES2 FS. And then ES prime FS prime. Okay? So, ganun lang yung analysis. I-add lang natin yung dalawang moment. Sorry, let's erase. MU1 and then MU2. Then we can solve the MU, right? So, sa Doubly, medyo complicated lang ang calculation ng Doubly kasi marami ng formula. So, in doubly reinforced ngayon, we can have the equation na T1, the tension 1, saan ba yan makikita? Ito, if you can see here, T1, okay? So T1 is equal to the compression steel as compression of concrete CC, okay? So, and then T2 is equal to CS. Saan yan makita? Ito yung T2 equals to CS. If you sum forces along horizontal, okay? And the AS, the total AS is equal to AS1 plus AS2. Okay? So, dalawang area ng steel na hati sa dalawa. One from singly and then the other is for doubly reinforced. Okay? So, the ultimate moment capacity ngayon, MU is equal to MU1 plus MU2. Okay? Where MU1, ano yung MU1? Ito yung MU1 created by the couple of concrete and steel. MU1 is equal to MU minus MU2. Well, actually, ito yung kinakompute natin na phi MN max from the singly reinforcement. Okay? So how to solve MU1 here? Looking at the figure, MU1, we can use the compression concrete CC times the couple distance of couple D minus A over 2. Ang MU2 rin, pwede tayong mag-start sa compression steel. Ayan. And then the moment arm, D, ano yung moment arm dito? Yan, ito yung D minus D prime. So we can write D minus D prime. The same, the Fs prime is equal to 600 C minus D prime over C. Okay. Now for balance condition, phi is equal to 0.65, wherein we can solve the C balance. Pareho lang ito ng formula 600 D over 600 plus Fy. Let me add section. Okay. Now for maximum condition, Cmax, ganun pa rin ang formula, 3 over 7 of D, where phi is yung transition, 0.65 plus 0.25 times 800 minus Fy over 1000 minus Fy. Okay, guess you know the formula. Okay, so in concrete design, especially for beam, mayroon tayong dalawang approach. First is design, second is investigation. So sa design, um, ang designing is we determine AS and AS prime. Okay, given determine AS and AS prime given MU. Okay, so given yung moment, and then we design the number of reinforcement. Yun yung tawag na designing. Other term is investigation. Ano yung investigation? Okay? Hinahanap natin ano yung maximum moment given AS and AS prime. Okay? So, ang designing, wala pang section, pero meron ka ng moment. Then you solve the section given the moment. In investigation, we have the moment, we have the area of bar and then the section. Meron na tayong section and then we determine the maximum moment. Okay? So, kumbaga, in practice, parang itong pangalawa, itong investigation, para bang mayroon ng building dyan and then ipapatrabaho na lang sa iyo as an engineer, ipakalculate kung safe ba yan na building. Okay? So in designing, you start from the scratch and then you calculate the number of rebar, the section of the beam. In investigation, ayan na yung section, ayan ang building, nakatayo na. And then you just investigate kung sufficient ba yung sections at saka numbers ng reinforcement for a given MU. Okay? So, ang example natin ngayon for this topic, I will give example on designing And then I will give also example on investigation. Okay, so let's solve the first example. So I will not draw, maybe I can draw here. We have a section of a beam, okay, where B is 300. So let's say this is 300. And then D is, ito yung D natin, 490. D prime is 60, meaning ito yung D prime. Okay? And then, given yung MU. Given yung MU, 600 kilonewton. And then the properties, Fy 27.6 megapascal. And then sorry, FC prime and then FY 276. Now, ito na ngayon. Determine the AS and AS prime. Okay? So, let's design the reinforcement. Assuming meron na tayong B at saka D. Okay? So, the first step is always determine, ang first step talaga natin always is determine if doubly or singly. So how do we determine if doubly and singly? Paano yan? We solve the phi mn max. If this is the capacity of the section, if this is greater than mu, singly. Okay? But if less than mu, then we say doubly reinforced. Okay? So let's check. We have the formula to how to determine the phi mn max. Okay, in our singly reinforced, phi mn max is equal to phi cc, that's compression of due to concrete, times d minus a over 2. Okay, so how do we determine a? We start from the Cmax. Cmax, that is the maximum neutral distance of neutral axis to the top of the beam. So we have 3 over 7 of D. So this is 3 over 7, 490. Ang D natin is 490. This is 210 mm. Then we compute A. A is beta 1 C, right? So in this case, C max. So we can have, what is beta 1? So remember, beta 1, for less than 28 megapascal, beta 1 is, um, beta 1 is 0.85, okay? So this is 0.85 times C max 210. We have a value, I've forgot to calculate. Let me calculate. 0.85 times 210. We have 168. Sorry, not 168. This is 178.5. Okay? Now, for maximum condition, ang phi natin is equal to 0.65 plus 0.25 times 0.25, 800 minus 276 over 1,000 minus 276. So we got our fee of 0.831 here. Okay? So let me add page. So from here, ito yung phi mn max is equal to phi 0.831 cc. Ano yung cc? Compression ng concrete. This is 0.85 of fc prime. Remember? 27.6 times AB. Right? Sulat ko na lang. Um, oh, wait. My pen is nag-lowbat yung pen. I don't know how to pause the recording. Can you pause this one? Mm-hmm. Diba, CC is 0.85 FC prime AB, right? So this is 27.6 FC prime. Ang A natin is 178.5. B, we have our B of 300. Now times D minus A over 2. Ang D natin is 490 minus 178.5 over 2. So, solving this one, we have VMN max is 418.371 kilonewton meter. Okay? So this one is 418. Now you need to compare that to our MU, 600. If you write that, VMN max is less than MU. Okay? So meaning, yung section ng singly reinforced concrete natin is not enough for the actual load MU. So we cannot use singly reinforced. So that means this is, sorry, doubly reinforced. Okay? Now, so let's start with the doubly reinforced. So meron na tayong MN1, MU1. Di ba ang MU1 natin is equal to Phi MN max. So meron na itong MU1 which is 418.371 kilonewton meter. So that we have to solve for MU2 which is equal to MU minus MU1. So this is 600 minus 418.371. This is equal to 181.629 kilonewton meter. Okay. Then, let's check. Ito yung mga makapadugay sa calculation. Check if steel yields. You always have to check if steel yields. Okay? So, Fs, ano yung pag-check? Solve natin yung Fs. If it is greater than Fy, then still yields. But if less than Fy, still does not yields. Then we have another computation kung that greater than Fy. So let's start with the tension steel. 600 times D minus C. Ito yung formula, right? 600 times D minus C. So this, you have 600 times 490 minus 210. Yun yung C natin, right? C, ito, 210 over 210. So the result is 800 megapascal. This is greater than Fy. That means ang tension still yields. Okay? Now, sorry, sa Fs prime, ito yung compression still. So the formula is 600, diba ha? Careful with this. C minus D prime over C. Okay? Actually, we can uh, solve for this equation. But we have no time, so we just use directly the equation. 600 times C 210 minus D prime, or D prime is 60 over 210. So the result is 428.571. This is still greater than Fy, 428. Kasi ang Fy natin is only 276. Okay? So we say that the compression still yields. Let me add page. Now, kung nag-yield lahat, meaning ang Fs is equal to Fs prime is equal to Fy, which is equal to 276 megapascal. So yung value ng Fs prime natin at saka Fs is equal to 276. Okay? So we can now solve the area using the equation CC is equal to T1. Ayan, establish natin una. Ano yung CC? 0.85 of FC prime AB. This should be equal to tension 1. Ano yung tension 1? AS1 times, sorry, Fy. This time we'll use Fy, di ba? Fs yan dapat. Fy kasi nga, Fs is equal to Fy. So, this is 0.85 of FC prime, 27.6 times A, 178.5 times B of 300 should be equal to AS1 times 276. From here, we can solve AS1, where our AS1 is equal to 4551.75 mm squared. Okay? So, yan yung AS1. Saan nga yung AS1? Let's go back here. Ang AS1 is ito yung AS1 natin. Ito yung AS1. You can see that. Yan. Then, let's solve AS2 and AS prime. So, here we have C2, I'm sorry, can't use other color, right? C2 is equal to T2. Ano yan? Yung C2 natin is AS prime. FS prime is equal to AS2 FS. Okay? Summation of forces lang ito. Ng second couple natin. Compression versus tension here. So, ang AS prime natin, which is unknown, times Fs prime. Ano yung Fs prime? Equal to Fy. 276 equal to AS2 276. So, kung ang both steel mag-yield, pareho sila ng Fs, the same ang Fs at saka Fs prime and Fs, we can say that As prime is equal to As2. Okay? So, meaning, if we go back to our illustration, kung mag-yield ang steel natin, these two are equal. AS prime and AS2. But may mga cases na mag-yield ang AS prime, ang AS2 hindi. Okay? I mean, ang mag-AS prime or ang AS. So, pwedeng hindi sila mag-yield sabay. Yun yung makakahaba ng calculation, which we will go through in the succeeding example. Okay, now let's say AS prime is equal to AS2. So, paano makuha natin yan? MU2, meron tayong formula ng MU2 is equal to phi CS times moment arm ng doble natin is D minus D prime. Now, ang MU2, meron tayong value ng MU2. Ito, 181.629. So, 181.629. Lagyan na natin ng times 10 to the 6 para maging Newton mm. Equals to phi. Ano yung phi natin? Phi is ito, 0.831. 0.831 times compression ng steel. Sorry. Yes, compression ng steel is ASFY. So, ito na yung hinahanap natin. AS prime times 276 Fy times D 490 minus 60. So, we have our AS prime is equal to 1841.648 mm squared. So, ang AS2 rin natin, di ba? Here, you can see, ang AS2 is equal to AS prime, which is equal to 1841.648. Okay? So, meaning, ang section ng beam natin sa taas, ito yung AS prime. Ito yung needed niya. 1841.648 mm squared. Ang total tension, ito, AS. So we know that AS is equal to AS1 plus AS2. So ano yung AS1 natin? Nasolve natin yung AS1. Saan yun? Ito, 4551. So 4551.75 plus AS2 natin, 1841.648. Wherein AS or the total area, ito na yung AS, is equal to 6393.0 398 mm. Okay, and then let's put this. Oh, sorry, erase. Yan. So ito yung hinanap natin, total area ng rebar sa baba and then total area ng rebar sa taas. Okay, so I will cut the example here, but in the next video, I will add three more examples for um, investigation problem. This one is designing problem. We given MU, we determine the area of par. So medyo mahaba nga lang yung uh, doubly reinforced. Pagdating natin sa investigation na doubly reinforced, mas mahaba pa dito kasi may mga cases na yung steel hindi mag-yield. Okay? So, but here we can control. But most of the time, ang still mag-yield dito sa designing. But in investigation, yun na nga, hindi natin control yung area ng rebar. So, kung ano nakalagay doon, we just investigate. So, ganun rin yan. So, pag practice ninyo, someday you become a professional engineer, may mga instances na may mga building na natayo and then walang engineer or may engineer man hindi na mahanap, ngayon pa-investigate kung safe pa ba siya, right? Kung safe, let's say, mayroong two-story na residential, then they want to convert it um, to a restaurant. So ngayon mag-hire sila ng engineer. Ipapacalculate sa kanila kasi yun na yung mga dimensions ng mga member. Mayroong beams, columns, ganun. Hindi na ma-change. Or pwede pa i-upgrade if kung kailangan talaga. But the owner has to hire an engineer. It's gonna be you. And so you have to investigate now if yung existing na mga section ng beams ng mga members is sufficient for the new function of the structure, which is, let's say, a restaurant. Ganon, yung residential na bahay gawing restaurant. So ipakalculate ngayon sa iyo. Yun. Ang tawag doon is investigation. Ganon. May mga project rin na mga walang building permits. Ngayon, biglang i-convert nila to commercial. Ngayon, when they apply for business permit, they have to have a, a building permit. So ngayon, wala silang building permit kasi ginawa nila without the permission. Now, you will do a analysis ngayon na as built ngayon kasi andyan na yung building. Ngayon, ikaw na lang mag-analyze kung safe yun. So, ngayon, yung may mga cases na gano'n na may mga sections na at saka mayroong mga number of reinforcement. Ang challenging lang is determining kung ano yung number of reinforcement doon sa loob. Kasi although may mga techniques like rebar scanning, may mga techniques na gano'n, but medyo mahal rin kasi yung mga device na gano'n. So, it's very challenging how to estimate, how to investigate kung yung in the field kung ano yung actual na reinforcement doon. Okay? Sometimes gina-magic na lang or may isang section ng beam na sisirain mo, although not suggested. Pero may mga case na gano'n na parang ano mo na lang na ma-estimate kung ano yung number of reinforcement. Anyway, maraming complications pag gano'n. But and that's the way of investigation. Mas maganda talaga yung designing kasi wala pa. And then you have the freedom yung mga dimensions. Pag investigation, wala. Andiyan na yan siya. And then you just uh, calculate yung capacity ng section. Alright? So, make sure to watch the video. For the succeeding examples, we will solve three investigation problems. So may mga mag-yield lahat, may May isa hindi mag-yield, yung isa naman, and then palit naman na hindi mag-yield, ganun. Okay? So that's gonna be in the next video kasi mahaba na. So baka boring na masyado. Alright, see you on the next video.